Namaste to all my dear students. I, Narendra Singh, welcome all of you in Antivirus YouTube channel. Hope you are doing well in your study and have started preparing your annual exams. Today, I will discuss with you an important paper of physics titled Statistical and Thermal Physics, which is taught in BSc second year class. In this video, I will discuss important questions which are asked in annual exam theory of 50 marks. But first of all, I will discuss briefly about number of credits, distribution of marks, scheme of examination, and at last there will be discussion on important questions which are frequently asked in your annual exam of this paper. So let's talk about number of credits. Total credit of this paper are 6, out of which 4 credits are from theory and CCA. CCA means continuous comprehensive assessment, which is also called assessment, and 2 credits are obtained from practical exam. Distribution of marks of this paper will be like this. In total, this paper is of 100 marks, in which theory of 50 marks is asked in annual exam, and there is a CC of 30 marks, and there is also annual practical exam of 20 marks. So 50 plus 30, 80 plus 20, 100. Let's talk about the scheme of examination. First section is your A section, and it is compulsory, and it is constituted of 7 parts, and it is question number 1, and all questions are asked from all chapters. Each question is of 2 marks. So this question number 1 is of 14 marks. Then section B is asked from first unit, which contains 2 chapter number 1 and 2, and question number is 2 and 3. Out of 2 and 3, we have to attempt only 1 question, which is of 9 marks. Then section C is asked from second unit, which is also constituted of 2 chapters, chapter number 3 and chapter number 4, and question number is 4 and 5. Only we have to attempt 1 question out of these 2 questions, and it is also of 9 marks. Then section D is asked from third unit. It also contains 2 chapters, chapter number 5 and chapter number 6. Question number is 6 and 7. Only we have to attempt 1 question, and it is also of 9 marks. Then there is a last section, which is E. This is asked from unit number 4, which is constituted of chapter number 7, 8, and question number is 8 and 9. Only we have to attempt 1 question. It is also of equal marks, that is 9 marks. So in nutshell, we have 5 sections in question paper out of 5 units, and in total these 5 units contain 8 chapters, and in total there are 9 questions in question paper, and we have to attempt 5 questions, in which question number 1 contained in section A is compulsory. So this paper is of 50 marks. I am talking about only of theory paper. So let's talk about important questions. Unit number 1, which is constituted of chapter number 1 titled Basic Ideas of Statistical Physics. So important question number 1 is, what is the meaning and importance of the principle of equal a priori probability in statistical mechanics? Question number 2, discuss in detail the distribution of 4 different particles in 2 identical compartments and tabulate the result. This is important questions. You have to take 4 different particles like A, B, C and D, and have to distribute in 2 different compartments, and have to calculate their thermodynamic probability, macrostate, microstate, etc. Question number 3, what are constraints? Describe the effect of constraints on the system. So system has to obey some constraints. Question number 4, prove that probability of macrostate is equal to thermodynamic probability. We have to prove this equivalence of two probability. Question number 5, differentiate between. This is very basic and asked in your exam. Differentiate between microstate and macrostate. Number 2, probability and thermodynamic probability. Number 3, accessible and non-accessible states. Then chapter number 2, titled Distribution of Particles in Compartments. Let's take its first important question. What do you mean by the most probable state? Derive an expression for probability of this state corresponding to distribution of n particles in two identical compartments. This is very important questions. Question number 2. Discuss in detail the distribution of 4 different particles in two identical compartments and tabulate the result. Question number 3. For n distinguishable particles to be distributed in two compartments, prove that the thermodynamic probability of macrostate is given by this expression. We have to prove this. Question number 4 is, prove that for a dynamic system, the fraction of the total time that the system spends in any particular macrostate is proportional to the thermodynamical probability for that macrostate. Next question is, we have taken this question earlier also. Question number 6 is, discuss the distribution of n distinguishable particles in k compartments of n unequal size. In unit number 2, first chapter is types of statistics in physics. First question is, explain the terms position space, momentum space, and phase space. What is the purpose of dividing phase space into cells? What is the minimum size of phase space cell in classical and quantum mechanics? So you have to describe different spaces: position space xyz, momentum space px, py, pz, and phase space is composition of these two spaces. Question number 2, distinguish between classical statistics and quantum statistics. So first of all, we have to differentiate between both mechanics, then compare Maxwell Boltzmann, which is classical statistics, and Bose-Einstein and Fermi-Dirac statistics. Both are quantum statistics. So we have to differentiate in it in the tabular form of these three statistics. Question number 3. Briefly discuss the Zeroth and Co experiment for verification of Maxwell-Boltzmann distribution law of molecular speeds. Question number 4 is, explain following terms. First is bosons and fermions. So we have to differentiate between these terms. Second is occupation index, which is equal to Ni upon Gi. N is number of particles and G is number of cells in which those particles are distributed. Number 3 is the concept of indistinguishability, which arises in your quantum mechanics, which may be Bose-Einstein or FD statistics. Question number 5. Derive Maxwell-Boltzmann law of distribution of speeds. Show that the number of molecules in speed range from v to v plus dv is given by this expression. This is a very important question. You have to derive this expression. Question number 6. Define and derive expressions of mean speed, root mean, square speed, and most probable speed of molecules. Also establish a relationship between them. So derivation as well as numerical based on these three speeds are also asked in examinations. Question number 7. Starting from basic assumptions, derive the relation for the occupation index. So this is basic relation which we derive in all three types of statistics, whether it is MB, BE or FD. This is also known as Bose-Einstein distribution law. Question number 4 of unit number 2 is Bose-Einstein and Fermi-Dirac statistics. It's a very important topic. Number 1, discuss or compare MB, BE and FD statistics, and also show that for energy greater than kBT, kB is your Boltzmann constant and T is absolute temperature, the quantum as well as classical statistics yield same result. In this approximation, all three statistics give same results. Question number 2, what are basic postulates of Bose-Einstein's or BE statistics? Derive an expression for the most probable distribution of particles of a system obeying BE statistics. Hence, deduce Planck's law of black body radiation. This is very important question of this chapter. Question number 3, starting from BE distribution law, derive. Number 1, Planck's law of black body radiation. Number 2, Wien's law of energy distribution. And number 3, Rayleigh-Jean's law. So we have to derive these three laws starting from Bose-Einstein distribution law. Question number 4, starting from Planck's law for black body radiation, derive Wien's displacement law of energy distribution, then Stephen's law. This is also important question. Question number 5, what are basic postulates of Fermi-Dirac statistics? Derive an expression for the occupation index given like this expression for the most probable distribution of the particles of a system obeying FD statistics. Question number 6 is, what is electron gas? And it is also called Fermi gas or Fermi cloud. Derive an expression for energy distribution of free electrons in a conductor using FD statistics. This question is asked again and again in your exams, and it is also important if you, while solving your numericals. Question number 7, define Fermi level and Fermi energy. Derive an expression for Fermi energy. Do electrons have energy, zero energy at 0 Kelvin? If not, explain why. So at 0 Kelvin, there is a level below which all energy levels are filled and above which all energy levels are empty. This level is called your Fermi level, and energy corresponding to this level is called Fermi energy. Question number 8 is, using Fermi-Dirac electron distribution law, show that the average energy of electron is given by E is equal to 3 by 5 Fermi energy. Again, using Fermi-Dirac energy distribution law, show that the average speed of an electron at 0 Kelvin is given by V is equal to 3 by 4 Fermi velocity. So we have to derive expression for average energy and average velocity, and have to remember these for solving numericals also. Then unit number 3, which is constituted of chapter number 5 entitled Entropy and Laws of Thermodynamics. First important question of this chapter is, what is a thermodynamic system? We have to define thermodynamic system. Then classify thermodynamic system on the basis of its interaction with surroundings. So closed system, open system and isolated system, we can differentiate between them. Then question number 2 is define following terms which are basic of this chapter. Number 1 is thermodynamic state, PTV. Number 2 is thermodynamic variable, PTV mu. Free energy, C, intensive thermodynamic variables, and then extensive thermodynamic variables. Question number 3, what are thermodynamic processes? How are they classified? Question number 4, what is PV diagram and it is also called indicator diagram. What does it signify? So work done in the process is calculated or estimated from PV diagram. This is its significance. Question number 5 is, what is Zeroth law of thermodynamics? How this law leads to the concept of temperature? Next question is, state the first law of thermodynamics and define internal energy from it. Hence derive a relation between molar specific heat of a gas, that is Cp minus Cv is equal to R. What are limitations of first law of thermodynamics? So first of all, we have to define first law of thermodynamics. Then from this law, we have to extract the concept of internal energy. Then derive this important derivation and also highlight the important limitation of this law. Next question is, what is heat engine? Explain its principle, working and efficiency. Why is efficiency of heat engine cannot be 100%? This is your Carnot engine. Next question is, give two statements of second law of thermodynamics and show that both are equivalent. So we have to argue for this equivalence. Question number 9 is, define isothermal process. Isothermal, iso matlab same, thermal matlab temperature. The process is having the same temperature. Then show that work done by n moles of an ideal gas during volume expansion from V1 to V2 at temperature T is given by this expression. So we have to derive and also remember this expression of work in isothermal process for solving numericals. Question number 10, define adiabatic process. In adiabatic process, heat content of the process remains same. Show that work done by n moles of an ideal gas during volume expansion from V1 to V2 at temperature T is given by this expression. This may be like this. So we have to derive expression for work and also remember this expression for solving numericals. Question number 11 is, define entropy. This is very important concept. Define entropy. What is its significance? Show that entropy of perfect gas remains constant in a reversible process. S is constant in reversible processes. Question number 12 is, 1 mole of a perfect gas is given infinitesimal small amount of heat. Find expression for the change in entropy of the gas. So we have to derive expression ds is equal to dq divided by t. Question number 3, what is ST diagram? Earlier we have discussed about PV diagram and it is ST. S mean your entropy and T is temperature. Using this diagram, derive expression for the efficiency of Carnot heat engine. Question number 14 is, what is Carnot engine? Derive an expression for its efficiency, which is given like this: 1 minus T2 minus T1. T2 is temperature of your sink and T1 is temperature of your source. Next is state and prove Carnot's theorem. There is also theorem. Question number 16 is, discuss the working of the refrigerator as a heat pump. Prove that coefficient of performance of the engine is given by like this: E is equal to Q2 divided by Q1 minus Q2, where Q2 is heat of your sink and Q1 is heat of source, and in term of temperature T2 divided by T1 minus T2. So we have to remember these expression of efficiency and performance of coefficient of performance for solving different numericals. Question number 17, define a reversible and irreversible processes. Show that entropy of a thermodynamic system remains constant in a reversible process. Question number 18, 1 mole of a perfect gas is given infinitesimal small amount of heat. Find expression for change in entropy of gas. We have taken this question earlier also. Question number 19, explain that second law of thermodynamics can be explained or described by the law of increase in entropy. It's an important question. We have to explain second law by using the concept of entropy. Next question is 20th question. Explain Seebeck, Peltier and Thomson effect. Then show that thermo EMF, electromotive force produced by thermocouple, is given as. This is mathematical expression where the letters have their usual meanings. Question number 22. Define Peltier and Thomson coefficients, derive the relations. We have to derive this relation. This is asked in annual exam. Next question is, for a thermocouple, show thermodynamically that. You have to derive this expression also. Question number 24. Discuss the meaning and significance of heat death of universe. Then chapter number 6 of this unit is statistical interpretation of entropy. This is smallest chapter of your book. There are only 3 or 4 derivations in this chapter. Question number 1. Derive the relation S is equal to K log W, where K is your Boltzmann constant and W is thermodynamic probability. Hence, give the statistical definition of the entropy. So we have to define entropy in terms of your thermodynamic probability. What are its units? We can derive its unit from this mathematical expression. Question number 2. Starting from the statistical definition of entropy, show that when an infinitesimally small amount of heat del Q is added to a system, keeping its volume and number of particles constant, the change in entropy is given like this: ds is equal to del Q upon T. We have to keep volume and number of particles constant. This is also important question, derivation. Then question number 3. Discuss additive nature of entropy by considering suitable examples. Show that entropy is an extensive parameter. So entropy is example of extensive parameter. Question number 4. What is disorder? Entropy and disorder are interlinked. Higher the disorder, higher will be the entropy of the system. How does entropy measure disorder? Why does a natural system always tend to change in a direction of increasing entropy or disorder? So this is your second law of thermodynamics, which can be linked here. Then next is state third law of thermodynamics. What is its significance? Unit number 4, which is constituted of chapter number 7, entitled Maxwell's Thermodynamic Relations and Their Applications. So first question is, what are thermodynamic potentials? Heat, enthalpy, free energy, like these all quantities are your thermodynamic potentials. Derive Maxwell's 4 thermodynamic relations. Question number 2. Derive following Clapeyron's equation of latent heat. This is very important relation, which gives the variation of pressure with the temperature. Question number 3. Using Maxwell's relation, prove that for a perfect gas, Cp minus Cv is equal to R. We have to derive this expression by using Maxwell's relation. And for real gases or van der Waals gases, this expression is like this: Cp minus Cv is equal to R into 1 plus 2A upon RTV. Question number 4 is derive energy equation. You have to derive these equations using 4 Maxwell thermodynamic relations. Show that for an ideal gas, variation of internal energy with volume at constant temperature is 0. We have to prove it. And for a real gas, the variation of internal energy with respect volume at constant temperature is equal to A upon V square. A is constant here. Question number 5. Prove that Maxwell relation leads to. These are important derivations or relations which we have to derive. Question number 6. Prove the thermodynamic relations. These equations are called TDS equations. First is this, second is this, and third one is like. So there are in total 3 TDS equations which are also mentioned in your syllabus. We have to derive these equations using Maxwell's 4 thermodynamic relation. Then last chapter, chapter number 8, titled Applications of Thermodynamics Relations. Question number 1. What is Joule Thomson effect? We have to define it. Show that the change in temperature in Joule Thomson expansion is given by. This is very important derivation. Question number 2. What is Joule Thomson effect? Show that temperature of inversion is given by Ti is equal to 2A divided by Br. 2A, Br, all are constants. Next question is, a wire is stretched adiabatically. Show that the change in its temperature is given by this, where symbols have their usual meanings. And then there is question number 4. What is thermomagnetic effect? Prove that temperature of paramagnetic substance decreases during the process of adiabatic magnetization. The most important question of this chapter. Thanks for watching and listening. Best of luck.